Okay, so the other form of imperfect competition is called oligopoly. What does oligopoly market structure look like? We have few to very few firms. I like to say if you can count the number of firms on two hands or fewer, then that's probably an oligopoly market. And usually the kind of firms that we're talking about are firms that are household names, firms that people recognize. In terms of size, because we have so few firms dominating the market, each firm is either large or very large. What about the type of product they produce? Well, in oligopoly, they can be either producing a standardized product or a differentiated product, and I'll explain what those are in a moment. Firms control over price. The firm has some control over the price that they charge, but they're always looking at their competitors' pricing decisions. In other words, whether or not they're selling a differentiated or undifferentiated product, they know that there's somebody else in the market that's roughly their size, that has roughly the same cost structure, and they can't charge too much more than than the competing firms. Otherwise, they might lose market share. Conditions of entry difficult to block because these firms are very large. It requires a large capital investment to get into an oligopoly market, which makes it difficult for new competitors to come in. You know, think of something like the oil industry, or think of something like making cars. The amount of investment that is required to get into making steel or making autos or making oil or producing oil is really high. So it's very hard for new competitors to come into the market. Price competition, that depends on whether or not they are producing an undifferentiated or differentiated product. If they are producing an undifferentiated product, meaning that what they produce is really not that much different from what a competitor produces, then there's a lot of price competition. On the other hand, if they're producing a differentiated product, they don't have to compete as much on price, and they probably wouldn't. So, example of firms who, when we talk about producing undifferentiated products like ExxonMobil and oil. ExxonMobil produces oil, so does Chevron, so does Shell. Or another example might be Alcoa in aluminum. Alcoa produces aluminum, but so does Reynolds, and so do other aluminum producers in other countries. Or like U.S. Steel in steel. U.S. Steel produces steel, but so does Marathon, so does Nucor, so does Bethlehem Steel, and then there's a lot of other steel producers in other countries as well. When we talk about differentiated products, think about the automobile industry. You have Ford, you've got Toyota, you've got GM, you've got Nissan. The cars that they produce are similar, but they're not identical. A Ford Mustang is not identical to a Toyota Camry. Or another example of a oligopoly market that's differentiated is, think of breakfast cereals. You have companies like Post and General Mills and General Foods. They're all making breakfast cereals, but Lucky Charms is not the same as Special K. So these are all examples of oligopoly markets, market structures. When we talk about undifferentiated oligopolies, they're selling a commodity type product. So there's not much of a difference between the ingot of steel that U.S. Steel produces and the ingot of steel that Bethlehem Steel produces. Or there's probably very little difference between the sheet of aluminum that Reynolds Aluminum produces and the one that Alcoa produces. So that's what we mean by an undifferentiated oligopoly. When we talk about a differentiated oligopoly, there's at least they're trying to get you to think that their products are substantially different. So, for instance, when you look at, let's say, cars, even though, like I said, you have Ford and Chrysler and Toyota and Nissan and Mercedes-Benz, they all sell cars. They're different enough that some people will gravitate, let's say, to a Mercedes because it's a luxury performance car. Other people might gravitate to a Japanese car like a Toyota or a Nissan because maybe they think it's less expensive and more reliable. Or if we think about like personal care products, right? There's a lot of different toothpaste that you can use to brush your teeth. There's a lot of different soap that you can use to take a shower. So those are examples of what we call differentiated oligopolies. One of the things that we look at in oligopolies is a thing called a concentration ratio. Well, actually, concentration ratios are going to play a more important role when we get to antitrust, which will be the next lecture. For the moment, the only concentration ratio that I'd like to introduce you to is what we call the simple four firm concentration ratio. So what we're doing when we look at the simple four firm concentration ratio is we're saying if we add up the market shares of the top four firms, what would that come out to? So interestingly, this is data from 2004 that looked at the top four firms in search engines. They had 98.5%. So if you think about who they are, they're companies like Google, obviously, Bing, perhaps. I'm sure Bing would be somewhere in the top four. Yahoo, maybe. I don't know anybody who uses Yahoo anymore, but or Ask Jeeves or something along those lines. This was one I thought was pretty interesting. Arcade, food, and entertainment complexes. The top four companies in this industry apparently have 96.2% market share. So we're probably talking about companies like Dave and Buster's and Chuck E. Cheese or something like that. It's a highly concentrated industry. Wireless telecommunications, the top four firms in this industry being Verizon, AT&T, T-Mobile. They have 94.7% of the entire market for wireless telecommunications. So when you see really, really high four firm concentration ratios like this, you can believe that it is probably an oligopoly market. All right, so why do oligopolies exist? Economic theory, economic wisdom believes that oligopolies exist because you have a declining long run average total cost curve. So, in a situation like this, if you're in this industry, it's sort of like go big or go home. Because if you don't get big and your competitors do, then they're going to be able to compete you out of business. They'll be able to undercut you all the time in terms of price, and there's very little you can do about it. If you choose to remain small, you'll kind of be a niche player and you'll have a precarious existence in this market. So, wouldn't it be better to become big, either by growing that organically or maybe merging with a competitor so that so the two of you would be better able to fend off the competition? So some examples of economies of scale in the oil industry, which is an oligopoly industry. This goes way, way back. It says while the cost of refining for a refinery with a $500 barrel daily throughput was 6 cents a gallon, if they could get up to 1,500 barrels a day, that would drop to 3 cents a gallon. Then, as refineries got bigger in the 1880s, the cost went down to 1.5 cents per gallon. And if they could get even bigger, which they did by 1882, then the cost could go down to a half a cent a gallon and then less than a half a cent a gallon. So one of the reasons why you see oil as an oligopoly business is because, again, it pays to get really, really big, especially if you're selling a standardized product. Your kerosene, which is what they were making in the late 1800s, or your gasoline is not that much different than the gasoline that somebody else is making, your competitor's making. Another reason for oligopolies in, let's say, a commodity type industry would be because if there are big swings in commodity prices, a bigger firm is better able to withstand those swings, right? You never want to buy high and sell low. So what would happen if, let's say, the market price for your input, crude oil, was really high, and then by the time you got done refining it into gasoline, the bottom had dropped out of the gasoline market and the price that you could get for your gasoline was really low. Well, you'd be buying high and selling low. Nobody wants to do that. But if you're a big enough firm, then that'll give you some pricing power when you buy, let's say, the input, and some pricing power when you sell the finished product. So that might be another reason. All right. Oligopoly markets. Can we rely on, if you think about what we've learned in terms of the output decision in perfect competition, monopoly, and monopolistic competition, it was kind of the same thing. We were looking at a situation where marginal revenue equals marginal cost. Even in perfect competition, Remember that price is equal to marginal revenue. So when the firm equates marginal cost to price, it's really equating marginal cost to marginal revenue. That was the same output decision that we saw the monopolist would make, and that was the same output decision that we saw the monopolistically competitive firm would make. Can we use that? Can we do that same trick in oligopoly markets? And the answer is it's going to require a lot of math, and it's not that the firm doesn't look at its marginal revenue and marginal cost, but we don't really have the tools to use marginal revenue, marginal cost in that. We'd be better off going with a thing called game theory. And in game theory, what we're going to do is we're going to look at how competitors in a marketplace react to one another as if they were playing a competitive game. So a little background on game theory. Some of the earliest pioneers of game theory. One guy was a guy named John Nash who won the Nobel Prize in 1994. He was a mathematician. He provided some of the earliest tools for game theory. A couple other Nobel laureates in the area of game theory was a guy named Thomas Schelling and Robert Aumann. Schelling was more of a theoretician, I guess you could say. He was also an advisor to JFK during the Cuban Missile Crisis. So, he was, I'm sure, applying a certain amount of game theory as to what we should do. And then Robert Aumann was his colleague, and Robert Aumann was more the mathematician, looked at things like infinitely repeated games. So if you play a game over and over again, what happens is you not only become better, but you have a better idea of what your opponents are going to do, and you can adjust your strategy based on what you think your opponent's going to do, and your opponent, of course, is doing the same thing. So you're not going to be tested on this, but I just want you to understand that a lot of what you learn in economics has applications beyond just the business world, beyond just making money. These are a list of books that this guy Schelling wrote. The Strategy of Conflict in 1960. This is before the Cuban Missile Crisis. Experimental Games and Bargaining Theory, again 1960. Arms and Influence, 1976. Micro Motives, Macro Behavior. So these are all books based on Schelling's understanding of game theory. And what you'll notice is most of these have nothing to do with making money, but they do have to do with things that are maybe equally important. All right, a little bit on John Nash. I'm not going to test you on this, but the reason I think this is interesting is because I always like to know what motivated people to do what they did. The math involved in that John Nash developed was highly advanced. A lot of people might think, well, he was doing it because he had some lofty goal. In reality, Nash was doing this because he wanted to figure out how to be a better poker player. And so he had this mathematical talent that he was trying to use to win more money at poker. Now, interestingly about Nash, he was a paranoid schizophrenic, which affected his academic career. And I'm not going to read this quote, but this is a quote of his acceptance speech when he won the Nobel Prize. You're supposed to come up and give a little speech, and so I think it's it speaks for itself. Let's put it that way. All right, so here's what we're going to do with game theory. We're going to assume that we have a set of players. A set of strategic actions available to each player. So each player has some options. The number of options can vary depending on the game. There are different payoffs, and these payoffs don't have to be positive. They could be negative. If you play the game badly, maybe you'll wind up losing, but there's different payoffs in the game. Each player is trying to achieve the best outcome that they can, okay, for themselves, obviously. Each player is aware that the game is interactive, meaning that what they do is going to be viewed by their opponent or somebody else, and then what their opponent does is going to be viewed by them. And then, of course, what you want to do if you're playing a strategic game, let's say like chess or something like that, is you want to be able to anticipate the other player's moves. That's not always easy, but that's the goal anyway. So then we get to a thing called Nash equilibrium. And the Nash equilibrium is something that occurs when people use the best strategy that they can, called the dominant strategy. It's the one that's going to make them better off regardless of what happens. So what we're going to do is we're going to play a game called Prisoner's Dilemma. Some of you may have been exposed to this in other disciplines, like let's say psychology. If you're not, or if you forgot what Prisoner's Dilemma is, we're going to go ahead and we're going to discuss the game, and then we're going to go through a trial run to see what would happen if two players, we'll make it simple, we'll assume that there are only two players and two outcomes, engage in a game of Prisoner's Dilemma and which strategy they should use. So the idea behind Prisoner's Dilemma is this. Imagine that a crime has been committed. Imagine that the police come to the scene of the crime and they find two people. But maybe they don't have enough evidence to convict these people of the big crime. Maybe they have some evidence. So if neither one of these talks, maybe they have a gun or something. Maybe the crime was like a bank robbery, and they can't really tie the criminals to the bank robbery because maybe they were wearing masks or something like that. But they find a gun, and if both the prisoners don't talk, if prisoner number one doesn't talk and prisoner number two doesn't talk, then maybe each one of them will go to jail for a year because they have a gun on them. All right. Now, if they can get prisoner number one to talk, what they'll do is they'll tell prisoner number one that you'll go free and you rat out your buddy, prisoner number two, and he'll do 5 years. Okay, so prisoner number one might be thinking, well, I don't want to rat him out, but I don't want to spend time in jail either. Going free would be better than 1 year. All right, if they get prisoner number two to talk, then prisoner number two will go free, and if prisoner number one doesn't talk, then he'll get the 5 years. So that would be for prisoner number two. You might be saying, well, maybe I don't want to rat out my buddy, but I don't want to go to jail, and it's better that my buddy go to jail than I go to jail, right? Now, if they get both of them to talk, then they'll each do 3 years. They'll use prisoner number one's testimony to convict prisoner number two. They'll use prisoner number two's testimony to convict prisoner number one, and each prisoner will get 3 years. So then the question is, what strategy should they use? And it turns out that each prisoner, if they look at the situation they're in, the best thing that they could do would be to talk. Now, why is that? Because if we go back over here, if you talk, if you're prisoner number one and you talk and your buddy doesn't, then you go free and he does 5 years. If you're prisoner number one and you don't talk and your buddy doesn't talk, then you're going to do 5 years. You're prisoner. That's all you're looking at is what's in your best interest. Well, 1 year is worse than going free, right? And if you don't talk, if you're prisoner number one and you don't talk, and your buddy rats you out, then you're going to do 5 years. So not talking doesn't look good. And if you're prisoner number one and you talk and your buddy talks, well, you're both doing 3 years, but 3 years is better than doing 5 years, right? If you're prisoner number one and you don't talk, and your buddy does, your partner in crime does, well, you're doing 5 years. So 3 years is better than 5 years. And it's the same thing in terms of prisoner number two. He's looking at the same payoff matrix. So both prisoners would be better off if they talked. Now here's the irony. If both prisoners could somehow communicate with each other, or if they could rely on the other one not to talk, that would be the better outcome because doing 1 year would be better than doing 3 years, right? But because they're both acting in their own self-interest, they wind up engaging in a strategy that makes them worse off than they would have been. Does that make sense? All right, so let's try this with a different set of payoffs. Imagine that we have a situation like this. Same thing, we've got two prisoners that have been found, two suspects that have been found at a scene of a crime. Imagine that there's no physical evidence this time, and let's say that if they can't get one prisoner to rat out the other guy, one suspect to rat out the other guy, they're both going to go free. Let's imagine, though, that this is a serious crime. I don't know what it would be, but imagine that if they can get prisoner number one to talk, and let's say prisoner number two says, no, I'm not going to talk because that would be ratting out somebody, that would be snitching, then prisoner number one will get 1 year, and then prisoner number two will get 20 years. Ooh, 20 years, that's a long time. And then let's imagine that if prisoner number one decides that he's not going to snitch, but his buddy rats him out, his partner in crime rats him out, then prisoner number one is going to get 20 years, and prisoner number two will get maybe 1 year for cooperating. Does that make sense? And if they both rat each other out, then they're going to get 10 years. In a situation like this payoff matrix is different from the previous one. You can see there's a lot more in the way of penalties if you don't talk and your buddy does, or your partner in crime does. But on the other hand, if both of you don't talk, then you both go free. What would be the optimal strategy? What is the best thing to do in a situation like this? I'll give you a little gap to think about this. And all right, enough time. In this instance, you should still, if you're faced with this, you should still talk, even though if you talk and your buddy talks, you're both going to get 10 years. If you don't talk, if you're prisoner number one, let's say, and you decide that you're not going to talk, but your buddy's in the other room ratting you out, you're going to get 20 years. Now, if you're prisoner number one and you do talk and your buddy doesn't talk, then he gets the 20 years. Better him than you, right? So the optimal strategy, the dominant strategy, would be for both prisoners to talk. Now, if they do, what's going to happen? They're each going to get 10 years, which would have been better than if they didn't talk. If both of them could somehow collude, then they would both go free, but it's not likely that that's going to happen. So, think about this the next time you hear like, "Oh, Murta and the mafia or snitches get stitches." What are those kind of things trying to do to, let's say, people who might get caught, to get them to change their strategy, right? You don't snitch out your buddy. If you do, you're going to get beat up or something like that. All right, let's do this. Let's end it here, and then we'll pick up with a business example of a duopoly using prisoner's dilemma.